Assalamu alaikum friends, how are you? My name is Zan. As you know, my previous topic was about the axial load, and today my topic is combined stress pressure vessel failure theory. Okay, today we discuss only the introduction. So, as should have become apparent from the preceding chapter, a description of the state of load at a point of a stressed member can be found by using the conventional formula and may involve normal and shearing stresses. Formal method for an alternate description of the state of stress at the same point in terms of principal stresses or the principal shearing stress and the associated normal stress were treated in chapter 8. In this chapter, the method of re-describing the state of stress in terms of principal stress will be applied to some particular cases of stressed members. As example, the principal stress is occurring in a circular shaft and a beam when they are subjected to some familiar loading condition will be examined. For this, the existence at many points of biaxial principal stresses, for example, both principal stresses different from zero will be shown. Moreover, since the earlier treatment of allowable stress was based on the uniaxial principal stress determined from simple tension or compression test, the resistance of material to biaxial stress will be discussed under the caption of stress or failure theories of material. For the development of this topic, the stress formula for thin-walled pressure vessel will be established. As experiments on pressure vessel provide information on the behavior of material under biaxial stress. Earlier in this chapter, the stress on including plane of the stress rod subjected to an axial force will be determined. Investigating of stress at a point. To find the principal stresses or the stresses on any inclined plane at a point of loaded member, the same basic procedure that was repeatedly using earlier must be employed. In static determining problem, the reactions are found first. Then a segment of the body is isolated by passing a section perpendicular to its axial through the point to be investigated by passing a section perpendicular to its axis through the point to be investigated, and the ecosystem and system of forces necessary to maintain the equilibrium of the segment is determined. The magnitude of stresses are determined next by the conventional formulas. Then one of an element isolated from the member, the computed stress are indicated. The sense of the computed stress is noted on this element by arrow, agreeing with the sense of the internal forces at the cut. Two sides of this element are parallel and two sides are perpendicular to the axis of the member being investigated. The definite relationship of the side of this element to the actual member must be clearly understood by the analyst. After the sketch of an element is prepared and the stress of the same kind are compounded, the stress may be determined on plane with any orientation through the same point. For this purpose, either analytical formulas or Mohr's circles of stress can be used. Thank you for watching.